welcome back to Dragonfly Engineering. So this week we're going to load the molds that we've been making the last several weeks, and these are the white ABS ring molds. So today I'm going to show you how we load the molds onto the molding machine and do a little bit of process optimization to make our first shot parts. So I hope you enjoy. So between mold changes on the platens of the molding machine, I like to spray it down with some WD-40, and that helps prevent any kind of rust from accumulating between your mold or your thermal isolation plates and the steel of your platens. Similar to spraying down the mill table when you put a vise on it, you know, you want some oil in there to help with rust prevention. And it also, I think, helps with when the mold actually clamps up. You can get very subtle sliding action sometimes, like a few microns or so, and that helps with that interface as well. So there's not so much friction and things that occur very microscopically when you clamp up on a mold, especially aluminum molds that can give a little more than a steel mold. And I'll do this on both sides of the molding machine. This is the rotary table for this dual shot machine. So this, for those who are new to the channel, this whole platen spins so we can overshoot two plastics with two injection nozzles, and basically two molds are loaded in this machine. And you can use this machine as a traditional molding machine as long as you've got two molds that are the same height in this platen, so you don't you know, torque your clamp when you clamp up on a single mold. You need both molds in there, even if only one mold is actively being used, which is probably how we'll run this part. And I'll get the other side, and then we'll be ready to load our, actually next we'll load our temperature isolation sheets, which basically helps keep the heat in the mold instead of heating up the whole platen. And then we'll load our mold. All right, so this is the heat protection plate, which is basically like a thick circuit board material, like a fiberglass. I think it's called Garlite, is what McMaster Carr calls it. But it's, yeah, it's fiberglass, high density, epoxy material. And I need to find the right mounting hole and screw this thing in. The previous mold ran a lot cooler, so I would just heat sink it straight to the steel of the platen. But for hotter molds where you're running ABS or polycarbonate or something, it's good to have this thermal insulator to actually get your mold up to temperature without heating up everything on the whole molding machine. Now, you usually don't have to run water through the molds because the high temperature setting of the mold itself, there's enough natural convection where basically the molds stay at temperature. And I rarely need to cool them off, actually, which is kind of nice. In this case, I probably will, because this is going to be a long run. I got the gantry crane positioned and our electric hoist ready to lift this mold up and load it into the second position of the platen, or the far position of the molding machine platen. We got it raised all the way up and over the molding machine, which is pretty high. Then I got a trolley on top there. Yep. And I'm going to pull this forward and drop it down. Probably need to go to the other side pretty soon. But you want to get the height of the alignment ring pretty much right. And then we'll stick this guy in. It just kind of sits in there. It's a little precarious. scooch it in. All right, it's keyed. There's a little bit of a reach to get these toe clamps in, but it's not too bad. Kind of develop a technique with my hand to hold and clamp it at the same time. May need more washers on this bolt. All right, there we go. We'll go around and clamp the top of the other one so it's kind of keyed in with the ring and ready to go. Okay. So now we'll bring the mold platen forward after we put our push rod in for the ejector plate. Okay, here's the second thermal isolation plate, which is just more of that gar-like material. And I think I should inspect it to make sure there's no chunks embedded in it. And I think I'll give it a quick clean with some WD-40. I'll be right back. All right, I'm back. Move that gantry out of there. Okay, so we got to string our push rod for the ejector plate, which ties into the ejector piston behind the platen of the molding machine with this long rod. But first, we got to string our heat isolator plate on the back of the mold so that we have efficient heating of the mold. And then I just screw this 1/2" 13 rod that's got an extension, and then basically like a coupler at the back that I custom made that will connect to the coupler that is on the end of the piston as well. This thing seems to be a little bent. Oh, it's just not tight. All right, so let's screw this in. All right, it's straightening up. If we needed more eject force, then I'd probably have a larger rod. And this machine comes with rods that are like 1 inch in diameter, or about 30 millimeters in diameter, for bumping a spring return ejector plate. But we don't have that in this case. So we are going to tighten this down. Let me get a wrench and make sure we're tight. And then I'm going to slowly close the mold platen towards the mold to pinch our heat isolator, and also make sure that there's nothing bad going to happen and crash the rod to the end of the ejector piston in the back. Now when I pinch the mold, this plate is still kind of loose. So sometimes I'll prop it up with some magnets, which are up here. And I can hold the plate so that it's not sitting on this rod, so it doesn't rub whenever we eject. But I'll lift this isolator plate up ever so slightly using some magnets that I kind of position on the platen itself to prop it up. So you'll see in a second. All right, so in setup mode, we are going to move the platen forward slowly. And I'm going to be going back and forth and checking. We're going to be making sure that our coupler does not crash. In fact, I need to screw the coupler on to the end of the ejector, which is pretty hard to see back there, so I don't know if I can record it or not. We will continue to move the clamp forward nice and slow and gentle with small little movements to make sure that no bad things happen. And I'm going to be continually checking clearance and seeing that our coupler on the end of our push rod connects with the coupler on the ejector piston. All right, so this is kind of looking up and in the back of the B-side platen, and you can probably just see like a torpedo looking coupler tip that's coming out of the back of the molding machine platen, and then there's a round coupler that's screwed onto the end of a piston right to the left of that indicator light. And then that combination needs to basically couple together, and then I put a cotter pin or a large bolt through that slot to connect the ejector push rod on the mold to the ejector piston on the molding machine. But I need to get a smaller extension rod because I'm just a little too, I'm like about 13 millimeters off on the travel versus the travel of the coupler. So yeah, it's really close. There's still a 1/4 inch here, and I've got an 1/8 of an inch to go on that coupler set. So yeah, I'm like an 1/8 of an inch or 3/16 of an inch off, or about 5 millimeters off. So I will find the shorter rod and then stick that in. And I use this high-tech vice grip to connect. Okay, and then I need to stick the bullet coupler back on. So I recall when I made this coupler, I made it such that the threads stop short of the cotter pin slot. So that's nice and tight, and it should pierce our coupler on the back of the ejector piston. So let's try this one more time. Here we go. Let's see if we're engaged. Okay, you can probably see how our bullet tip of our ejector rod coupler is starting to engage with the cylindrical part. And you can see basically when those two slots line up, so the ejector rod internal bullet shape will go into the hollow cylinder, and then I'll just run probably a M6 threaded bolt all the way through those two slots, and then we should be good to go for being coupled up for ejecting the mold. All right, so now I'm going to send this mold clamp home, and we should have a good engagement on the coupler. It's already pre-aligned, and the inner coupler is aligned in the cylinder of the coupler that's attached to the ejector rod of the molding machine, or the ejector piston. So I'm just going to keep inching forward. All right, so we should be there. Well, I moved the clamp forward a little bit more, but it seems like I'm fully engaged now in the back there. All right. So now we can kind of position our isolator slightly higher up with these magnet chunks. Just so we're not riding on that inner push rod for the ejector plate. You just got to lift it off a little bit and center it's good to center your heat isolating plate the best you can. And these magnets are thinner than the plate, so I'm not going to crush into the platen with them. Now we're still in setup mode, so all the pressures are low because we only have one mold loaded right now. So I'm just going to pinch this shut enough so that we can set our B-side mold clamps onto or lock down the mold to the mold sliding platen or moving platen. All right, that's it. We got 1 ton of force so far. Okay, so all we got to do now is stick this pin through the coupler in the back that connects the ejector hydraulic cylinder to the ejector plate of the mold. I've got this 1/4 inch bolt here, and I've chamfered the tip a bit, and this bolt has a non-threaded shoulder, and I chamfered the tip so that I could kind of start it into those 2 slots in the coupler the custom coupler I made in the back. So wish me luck. It's pretty much impossible to record, so you can just kind of watch me hopefully not swear too much as I attempt to get these 2 slots in this bolt aligned. Yeah, can't really see in here or do much of anything. So it's a lot of feeling around and hoping for the best.
In the heat of battle, my father wove a tapestry of obscenity that, as far as we know, is still hanging in space over Lake Michigan.
All right, I got this 3/16 hex to go in there. So, and I sort of pre-aligned the slots, so wish me luck. If I can get this bolt to go through. I may have to go to an M6, or I could try screwing it in. All right, I got it. So I had to screw the outer ring coupler or the cylindrical coupler out by 1 revolution so that the 2 threads mesh up and my slots line up, so I can now drop this screw down through the 2 slots and connect the couplers together. All right, let's see if I can show you that pin that I put in there. Into the innards of the molding machine, and there it is. That's the 1/4 inch or 1/4 bolt that went through the coupler and locked the ejector cylinder, which that thread, to the thread in the mold itself, and that nut at the bottom is keeping the pin in place. Sorry about the shaky camera. All right, let's open her up. There we go. And then we'll try the ejector real gently. Okay. Looks like it ejects forward and back. So we're good. All right, well, we can load the second mold into this region, the front region, which is going to be a little simpler since it doesn't have any ejection on the B side. All right, so this is a metal angled chute that the parts kind of fling out of, or not fling, but they slide on this powder coated metal surface, and it is on a hinge. Technically, it's, I think, an OSHA violation if you can reach under here at all, so I guess don't modify your machine, but I make it adjustable so I can put a bin here to catch the parts as they come out. Oh, and I don't have any employees, so I guess I don't have to worry as much about occupational safety because I don't have employees. But yeah, don't modify your machine. Insert disclaimer here. And we're going to be mostly interested in what's happening with that second mold there. So we got all of our gates closed, and I am going to load new plastic into the molding machine. We are up to temperature, so that's good. And so effectively we are going to load some plastic. All right, so I loaded plastic into the first injection unit, which is indicated by this indicator here, and I can squirt that out. I like to, when you first start up, you want to purge out some of the plastic that's been sitting in there as you heat up the barrel, because it can degrade, you know, kind of get toasty in there. All right, so we've got our first shot ready. Now we'll switch to the second shot and purge out the plastic that's in that barrel. Oh, actually, I'm doing the second one again. That's all right. Can't really see it too well. All right, so now we're looking through the safety gate of the first injection unit, and you can see some of the ABS has kind of drooled out. That's that cascade of plastic coming out of the barrel. So we will purge this barrel now. And you may have seen some plastic squirt out, and now we're going to fill the screw with the next shot, or the next charge is what they call it, and you'll see some of that plastic kind of dribbling out the front there. And you can probably also see that the needle indicator shows that we have filled with plastic. So I'm gonna purge it out again just to make sure we got good stuff. You see that needle move, and you'll see that there's a bigger lump of plastic in the front there. We'll go back to this guy, and that red needle in the injection unit itself, which is this whole thing, will show where the position of the screw auger is, which tells you how big your shot size or the amount of plastic you're loading. So hit that button, and you'll see how, you may be able to see that behind there the cylinder is turning, and then that red indicator is showing what the column of plastic is in the molding machine right now. It does like a really slow suck back. I need to figure out why it's doing that. Okay. Then you open the safety gate, and you get all the old nasty, all of this plastic out of here. I actually got some old crust from last time. See if I can get that out of there too. There we go. Okay, we should be ready to shoot our first parts. Okay, I think we are ready to go. So I'm going to set this thing to semi-automatic mode, and all I have to do is hit the start button, and it's telling me everything looks good, and close the door and hit cycle start. So you can watch the action with the camera here. Okay, so let's see what happens. Okay, the mold closed, it clamped up. And we're only at 150 tons, so that may be a bit of a problem. I might have to increase the tonnage on the clamp. So we injected injection unit 1, and that's the sound of injection unit 2 filling, and we've got about 1/3 of an inch of plastic left, or about 10 millimeters. So that's good. And we are refilling injection unit number 2. And now we're refilling injection unit number 1. And we should see these molds open pretty soon here. That was a little cooling time. Okay. We injected the first part off, and then we ejected the second part off. I don't have the catch bin down here, but yeah, here's the first part, the disc. Now the flange, since it's a new shot, is an undershot, so this is what we got. But let's keep molding more. Okay, so I'm gonna hit the cycle start button again. We're still in semi-automatic mode, so the machine will do one full cycle and then stop like it did before. And we're injecting both now. The timing is a little different because both injection units were basically up where they need to be in a normal cycle. Whereas the first shot, the injection units were all backed up so we could clear out the plastic. So we're loading up, or refilling the injection units. Sometimes there's a squeak on the second one, but I hear that with other molding machines too. Like the 90-ton squeaks sometimes when it's augering plastic in. Okay, we're gonna open. We still have an undershot, but hopefully you saw that two-part eject action. Okay, we'll hit it again. Okay, here we go, opening. That looks like a full shot. And you can see the two-step operation. So when the stripper plate advances forward, the tunnel gates actually break free from the part. And the tunnel gate is basically at the end of each one of those 3 channels that runs plastic to the tunnel gate. So since the tunnel gate is tunneled into the metal of the mold and there's an ejection operation, the part actually pulls away from the gate, which is under the surface of the mold at an angled like taper, and that angled taper creates basically like a little cutter for the gate itself, which is the opening that flows plastic into the cavity of the mold. And then when the part ejects, I've got ejector pins that will eject the ring off after it breaks its gate, and then the mold will simultaneously eject the runner with the tunnel gates themselves. And I can show you probably in a B-roll, but this is what we get. So this is what you get when the part leaves. So this little triangular cone shape with a broken off tip, that's what flows plastic into the mold. And then when the mold opens, this guy basically, the part is my finger, and this is all submerged in metal. And then when the part ejects, the part goes and then the tunnel gate goes, but there's a chunk of metal here which breaks this gate, and then the part falls out, and the tunnel gate, or the runner with the 3 tunnel gates, also falls out. So let's see that one more time. Hopefully that made sense. We'll hit cycle start. Pick loader. There you go. So hopefully you saw that. And then our cap ejects off the first mold. So let's do that one more time. So you'll see how these indicate like the status. So right now we're filling injection unit number 2, and you'll see that bar advancing. And now we're filling injection unit number 1, and this bar shows like how much plastic is loading into the injection unit. And then these show temperature. All right, let's see what happens. There we go. I don't know if I captured all that. Let's try again. So this shows our temperatures. Now we're refilling the injection unit number 2. And here we're starting to refill injection unit number 1. Again, there's a little squeaky sounds, but I think that's normal. We'll get ready to watch what happens with the second guy. Yeah. So hopefully you saw how those ejector pins broke. Tunnel gates broke as the part ejected. Let's try again. Yeah. I want to hit the tripod. One more time. I got a sprue that's stuck. You can probably see that guy right there. So since we're starting up, sometimes this happens. So what I'm going to do is go to manual mode, and I'll go around and pull that sprue out. Hopefully it won't be too much of a hassle. That's hot. So I'm going to use this rubber handle of this channel lock. It's not looking good. Oh, it just wants to come out of there too. This part of the mold is not part of the finished product, so if it sees a little bit of blemish, it's not the end of the world. All right, I'm gonna have to use basically a hot poker and melt this out. There we go. All right, I'm gonna hit cycle start. We're still in fully automatic mode. And we didn't have a clogged runner, so that's good. Oh, I get an interesting effect. You can see my face in the reflection right here and the mold. See, this is advanced editing techniques. So you can see the joy or dismay on my face as this next set of parts opens. All right. Okay, so we're good. And then the mold closes and we are in automatic mode. All right, so we had an issue with this mold here. Actually, not so much this mold, but its younger brother, which has a shorter flange, in that the three-way sprue and runner system with the tunnel gates would eject, but not completely eject off. And what would happen is I couldn't run this mold or the other similar mold to this in automatic mode, because the sprue would hang up just like you see it here. And I attempted to make the ejector pins more deep into the stripper plate of this mold, which is the black anodized part, but I could only go so deep before I started running into problems with the inner structure of the ejector pin hole. Of course, there's an airplane flying over. Anyway, so the result is I couldn't get bigger feet to push these tunnel gate remnants out of the mold. It just wouldn't work out with the geometry of the mold. So what I wound up doing to fix this problem is to make a Sprue Wacker, which is this contraption right here. And effectively what it is a dual acting air cylinder with a pivot, an adjustable lever arm, and then a plastic rod which whacks the hung up sprue off of the B side of the mold after the main part has ejected. And to demonstrate this, I can hit the manual switch on this pneumatic valve and you'll see what happens. Just like that. And then there's no more hung up sprue and I can run this machine in fully automatic. And I've actually molded several thousand parts using this Sprue Wacker mechanism. So if you'd like to see more about the Sprue Wacker, I have a whole episode where we fabricated that, a link in the description. And basically I ran about 1,500 parts, and here's some footage of me tearing down the setup for the next molding run after this. So, hope you enjoyed the show, and thanks for watching. Please like and subscribe, and hit the bell icon if you'd like to see more episodes. And have a good day. Goodbye.